Welcome back, everyone. Let's now test your new skills with your logistic regression exercise project. In this lecture, we'll have an overview of the project, and in the next lecture, we'll go over the solutions. Let's head to the notebook. Okay, here we are at the logistic regression project exercise notebook. The main goal is to create a classification model that can predict whether or not a person has the presence of a heart disease based off their physical features, such as their age, cholesterol levels, etc. We filled out a couple of cells for you, so you'll go ahead and run the basic imports, and then we have a data set which contains 14 physical attributes based off physical testing of a patient, such as a blood sample, and also a brief exercise test. And essentially, we have a field called the goal field, which is an integer, 0 for no presence of heart disease, 1 for presence of heart disease. So we have here a bunch of physical characteristics, and again, this target column, the goal column to predict, which is 0 for no presence of heart disease, 1 for presence of heart disease. We also have the link to the original source, as well as the original publication of this data set. Go ahead and run these few cells to read in the data set. It's under the data folder. It's called heart.csv. You can check out the data and then see the target is actually binary classification 1 and 0. We'll start off with some tasks for you to perform some exploratory data analysis and visualization, essentially checking out the data frame, doing some visualizations based off the target column, as well as a pair plot, and then a heat map of the correlations. After that, we'll get straight into the machine learning. Go ahead and do a train test split, scale the data correctly, and then you'll get to the logistic regression model. Now, it's up to you whether or not you want to use logistic regression CV or use a combination of logistic regression and grid search CV as we did in the previous lecture. Essentially, either way, we want you to perform some sort of hyperparameter search in order to figure out the best possible logistic regression model, or at least figure out the best C value for some sort of penalty term such as L1 regularization. So try your hand at performing a logistic regression model that actually has some regularization searching for the best hyperparameter there. After that, you can go ahead and report back the best optimal parameters. Specifically, the C value is probably what we're most interested in. And then we have some other questions here, such as reporting back the model's coefficients. Keep in mind, your model, depending on your grid search, may have different coefficients here. And then we have a bonus task for you. And we didn't show this in any of the lecture notebooks, but you should be able to do this given everything you've learned so far. Essentially, we want you to make a bar plot of the coefficients. So you'll link up those coefficient values to the actual features they represent, and then show a bar plot like this that is comparing the coefficients directly against each other. Then it'll be time to check your model's performance. So we want you to print out a confusion matrix here. Go ahead and plot it out as well, and then print out your entire classification report. Keep in mind, you may be performing slightly better or worse, depending on what model you actually ended up with. We're leaving your model choice a little more open-ended here. And then we also want you to create the performance curves, precision versus recall, as well as your ROC curve, true positive rate versus false positive rate. And for our particular split and CV model, we ended up using logistic regression CV in the solutions. We have AUC is equal to 0.96. And then finally, the final task is we have a patient with these following features, and it's come into the medical office. So you'll go ahead and take your model, and we want you to ask or answer the question, what does your model predict for this patient? And for convenience, we actually set up this array for you to pass into your model, and you should predict that this particular patient is class 0 with a very high expected probability. Okay, so that's it. We'll see you at the next lecture where we go over the solutions.